Okay, start recording. Now today we're going to enter integration. As you can see, we already completed differentiation. Just a recap in P3. Okay, chapter 1 algebra. Okay, chapter 2 we have exponential and log. Okay, and chapter 3 we have trigo. Chapter 4 we have differentiation. And chapter 5 we have integration. Chapter 6 we will have numerical methods. Chapter 7 I will have differential equation. Okay, today for this integration we are actually talking together 5 and 7 together. Okay, 5 and 7 together will be joined together, and number 8 will be vector, number 9 will be complex number. Okay, so this one already done, this one already done, this one already done, this one already done. Now we're going into 5 and 7 together. Okay, so now first of all, let's revisit the rule. Okay, we have a basic rule. Okay, for your introduction. Okay, just let you brief through about look through about all the formulas that you're going to do. Okay, we have basic rule. Okay, after that we have basic integration. Okay, so there are formulas. Okay, there will be rules about trigonometry, how to actually use trigonometry. We have advanced formula. Okay, and we have special formula with proof. Okay, this will be the formula that appear from the past years before. We have integration technique. Your P3 will be focused on integration technique. Okay, P3 will be focused on integration technique. There will be 3 techniques here. Then will be application. Okay, and comes to extra. So total of 42 formulas. Okay, the A, B, C, D, E, F, G, H actually appear like this. Okay, so according to the level of difficulty of first students learn about A, then after that go to B. When you enter B, you're expected to know about A. When you enter C, you'll be expected to know about A and B. When you expected D, you're expected to know A, B, C. Okay, as I say, your P3 focus on integration technique. That means you will need to know how to apply the formulas for A, B, C, D, E. Okay, so without further ado, let's see what are the formulas actually. Okay, so A, according to differentiation, if d dx of capital F equals to small letter f, then integrate of fx equals to capital F plus c. So this is called indefinite integration. Okay, integration. So this one just explain about the relationship between differentiation and integration. Number 2, if d dx of capital F equals to a small letter f, then I have a limit with a, b, and I have fb minus fa. Number 3, if we have the integrate of fx plus minus gx, so we can actually integrate them separately. Okay, in number 4, if I have a k times of fx, I can take out the k before I do my integration. Number 5, if I have a constant will go to kx. Number 6, if I have AB can actually switch the position of the limit, become negative minus of BA, okay, as you can see. And of course, students will be expected to know how to do improper integration from P1. This is to infinity and to asymptotes. Okay, so students should be familiar with these 7 basic rules. Then comes to basic integration. Okay, the basic integration here will be expressed as a direct reverse of differentiation. Okay, a direct reverse of differentiation. Okay, for example, number 8, okay, in differentiation, we bring down the power minus by 1. Here, we power plus 1 divided by the new power. For 9, if we differentiate ln, we go to 1 over x. Over here, integrate 1 over x, go to ln of modulus x. So the reason that we have modulus here is to keep it to be positive. Okay, number 10. Okay, if we integrate, if we differentiate ex, we get ex. Over here, if we integrate ex, of course, we get ex. Okay, as you can see, all the rules here are actually just application of rule 1 here. Okay, number 11, if I differentiate cos, I get a negative sign. So if I differentiate sine, goes negative cos. Over here from 11 and 12, you will see that we still are applying this rule. Sine differentiated go to cos, cos differentiated go to negative sine, negative sine differentiated go to negative cos. Okay, the blue arrow that we're actually referring is the differentiation. If it's an integration, it go backwards. Okay, go backwards. So you can see that differentiate of sine, integrate of sine is here. Integration of sine goes to negative cos. So you can actually go backwards. Integrate of cos goes back to sine. Okay, we're still following this rule. Number 13, okay, we know that differentiate of the tangent go to secant square. So therefore integrate of the secant square go to tangent. Number 14, okay, if we have a differentiate of the secant goes to secant tangent. Okay, I hope that you still remember the proof of the differentiation. Over here, integrate of secant tangent go to secant. Number 15, differentiate of cosecant go to negative cosecant cotangent. Over here, integrate cosecant cotangent go to negative cosecant. Number 16, differentiate of the cotangent go to negative cosecant square. Over here, integrate of cosecant square go to negative cotangent. Okay, number 17, okay, if I have an integrate of 1 over x squared plus a squared, will be 1 over a arctangent of x over a. So this one also a direct reverse of your in differentiation. Okay, differentiate of arctangent of x give us 1 over 1 plus x squared. Okay, so for rule, okay, from rule 8 to rule 17, okay, rule 8 to rule 17 here. Okay, so if x is in the linear form, okay, if x is a linear form is ax plus b, then change x into ax plus b for both sides and multiply right hand side by 1 over a. So let's see. So please understand this rule 18 here only true if it's a linear. Okay, if it's not true if it's not a linear. For example, if I integrate, if I'm referring to 13, you integrate of secant square of 3x plus 2. That means I will get tangent 3x plus 2 and over 1 over 3 time multiplied by 1 over 3. So as you can see how we apply the rule 18 here. Let's say I choose another one. Let's say I have rule 10. Okay, if I apply to rule 10, if I have integrate of 1, rule 10 is ex. Okay, integrate of ex, dx give us ex. Okay, if it's in the linear form, e of 3x plus 2 dx, then I will get 1 over 3e. Then I will get 1 over 3e 3x plus 2 plus c. Okay, so I don't want you to rush through the formulas. Okay, I will let you practice section by section. So it's better for you to get used to A, B, then slowly go to C, go to D, go to C, and so on. Okay, therefore the first exercise that you need to do is up to 18, the rule up to 18. So let's look at the exercises. Okay, wait for a while. Let me put in the answer as well. Okay, going to wait for a while. Going to finish. Okay, so for information, this rule uh, 17 here is a new syllabus. Okay, so therefore you don't really have this question in the old book. So this is the reason why, okay, over here 6b we have the old questions, then comes to the 8b here you have the new syllabus questions. Okay, so from this together, this one we practice for section A and B first, A and B for now. Okay, so if you got any questions you can actually text me. Okay, okay, so stop recording.